Hello everyone, now this is a 5-stage 3-generation composite cabin. In parallel, I will explain to you later the installation process. There are 6 outlets behind this equipment. The yellow one is the gas inlet. The lower one is the water inlet. This is the sewage outlet. This is the condensate outlet. This is the circulating water outlet. This is the circulating water inlet. This gas inlet. Our company standardizes a 50 centimeter hose. At that time, just assemble it by the gas company. The flange of the water inlet is welded with a single wire. Then add this external filter, and a union joint, and a valve. The valve should be in front of the filter. This is a DN40 pipe. It's 40 for each unit. Because our site, 5 units are connected in parallel, it uses a diameter of 125. If it's a single unit, a DN40 pipe is enough. This inlet pipe is connected to the lower port of the pure water tank, because this is a customized water tank, and the diameter of the pipe is thick. So it adds a butterfly valve. If it's a round water tank, a ball valve can be added. This valve is the same as the water inlet. The diameter of the pipe over there is. The valve here needs to be the same size. This sewage outlet, directly weld the pipe, and then connect it to the sewer. The diameter of the pipe, because this is a DN20 drainage port. If it's close to the equipment, you can use a DN25 valve. If it's far away, it needs to be thicker. Change it to DN40, because this is a 5-unit parallel project. So the drainage pipe below, we use a DN40 pipe. The condensate outlet can be made of PAR pipes with a diameter of DN32 and directly into the sewer. The condensate outlet and the sewage outlet must not be connected in series. They go their separate ways. This is a circulating water outlet. It should go upwards. If multiple units are connected in parallel, you need to add a one-way valve and then enter the pipe. Here we use a DN40 pipe. The 5 units are connected with 125 DN125 pipes. Take this circulating water outlet as an example. As long as it is screwed, you must wrap it with hemp rope and thread tape to ensure no leakage. For this screw and to flanges, a metal gasket should be added in the middle. Metal winding gasket. If it is welded, the welding must be beautiful and it can't leak. This is the inlet of the circulating water. It's the same as the water inlet, and the diameter is also DN40 for a single unit. If multiple units are connected in parallel, the pipe diameter, it depends on the situation on site. The circulating water inlet also needs a valve, a union filter, and a union joint in the middle. Then there is hemp rope and thread sealant. On the side of the equipment, there is also a circulating water outlet. It also goes upwards and enter the main pipeline, and finally return to the upper part of the pure water tank. There are 3 outlets on it. The 2 above are safety valves. The 2 safety valves can be connected into one pipe. It's a DN50 pipe. This needs to be let outside. The chimney outlet is 300. Each unit can use 300. It also depends on its length and a few elbows, because we are connecting 5 units in parallel for this project. So the main pipeline, we use a 1-meter diameter pipe. The material is stainless steel to 01. If the chimney on site needs a bracket, we can also make a bracket like this, according to the different lengths on site, to see how many brackets to make. Another way is to hoist it from above, but you must do it well. And safety protection. This is the steam outlet. It needs a one-way valve, clamp type check valve, and valve. Then there is a T-valve here. The valve leads to a pipe with diameter of 65. Because the DN65 pipe is a pressure pipe, and the DN40 doesn't need to be reported. 2 pipes of DN40 enter the header. After the steam outlet comes in, enter the header. Because we have 5 devices connected in parallel, there are 10 inlets, with 2 outlets on each. The inlet of this header, the diameter and valve. At that time, it needs to be determined according to determine the different sizes. A reducer will be added later. The insulation of the steam pipeline depends on the sales contract. It's usually rock wool with aluminum skin. If the sales contract, there are other requirements. Follow the sales contract. If brackets are needed on site, make sure there is a certain space between the pipes. There must be a certain space to leave space for the customer to insulate. But we need to install a bridge on the equipment in parallel. this bridge frame to run the cables. This is our distribution board. What we need to do is the power supply. Using 6 square copper wires, 3 live wires, 1 neutral, and 1 ground. You can see this is the yellow-green wire, which is the ground wire, and connected to the ground wire. Then this N is the neutral wire. L1, L2, and L3 are live wires. 3 live wires. Before we debug, we need to check all the terminals carefully, whether they are loose or damaged. Okay, that's all. As you can see, all the pipes on the site are all horizontal and vertical. It must be beautiful.